Hello again. In this video, we're going to approximate the area underneath a curve using the midpoint approximation method. But the twist here is that we don't actually know what the equation of the upper boundary curve is. We just know it as y is equal to f at x, as opposed to in previous videos where we were given the equation of that upper boundary function. So we're going to have to do some sort of eyeballing of the graph to sort of figure out what the value of the function is at the heights of each of the rectangles. So first things first, what we're asked to do is to use 4 rectangles to determine the area of underneath the curve from 0 to 4. So we have to divide these 8 squares up into 4 equal rectangles. So I think that's pretty obvious how we're going to do it. So we're going to have a rectangle that goes from there to there, and from here to here, and from here to there, and from there to 0. Now, how tall are we going to make those rectangles is dependent on the midpoint. Now, the midpoint of each of these rectangles would be right there. Okay, so that's the midpoint of the base. So if we just simply, see if I can show you a visual then. Right, so I'm just going to rise up from the base. And that right there will give me the height of the rectangle. This right here will give me the height of the second rectangle. So maybe I should draw these rectangles in before anything else. I could probably draw better rectangles with the drawing tool. So there is the height of the rectangle, so I'm going to approximate that like right there. And there's my first rectangle. Okay. My second rectangle, the height is a little bit lower, it appears, so I'm going to go right there. Okay, the third rectangle, I hope you can see. I'll just use the arrow again. We're going to go straight up until we hit the curve. Okay, that's the extent of the rectangle. So that's right about there. And then the fourth rectangle will be right here. Now, at the end of the day, just because my arrows happen to be black as well, it actually looks like I've got 8 rectangles, but I'm just going to make those arrows disappear here right away. Okay, and there they are. There are my 4 rectangles that I'm going to use to approximate the area. Okay, so let's do this. So area is equal to, I guess we're going blue. Area is equal to the width of these rectangles, which is just 1 unit, multiplied by the heights of each of these rectangles. So the height of the first rectangle, let's see, this is 12, this would be 14 right here. So I'm thinking this isn't quite 15, but it's awfully close, so maybe I go 14.7. And it is an approximation, so I think 14.7 is reasonable. This over here, we're a little bit lower, so I'm thinking maybe that could be about 14.5. Okay, and then this one looks like it's spot on 12, or at least close enough to it that we can use that as the approximate height. And then this one right here looks like it might be around maybe just a little bit above 7, so I'm going to strategically pick 7.3 because I know 7.3 plus 14.7 will give me 22. Okay, so when I add up those numbers inside, I get 48.5 times 1, of course, is 48.5. Okay, and actually, square units, right? We don't actually know what units they are, but they're area, so we should put square units. And that's it. That's how you determine the area, or I guess it's not the area, but the approximate area underneath the curve when you don't actually have the equation of the function.